Right. Today, I would like to explain the application of Euler's theorem. First, just let me recall what is meant by Euler's theorem in few seconds. Euler's theorem. Actually, it is a generalization of the Fermat theorem. So, in order to apply the Euler's theorem, first you need to have an integer, and you need to have a positive integer whose GCD is 1. Then we can write it as a power pi of n is congruent to 1 modulo n. That means in order to apply the Euler's theorem, we can have an integer which is relative prime to n. Then a power pi of n is congruent to 1 modulo n. Using this theorem, I am going to solve some problem. So prove that a power 37 is congruent to a modulo 1729. Right. Now fix any integer. The question is whether to 1729 is a prime number or not. So it is actually, it can be expressed as 3 into 13 into 19, right? I'm going to solve this problem in two cases. So let us take first case. What is the GC? If you take the GCD of a comma 3, means actually 7, sorry. If GCD of a comma 7 is 1, or GCD of a comma 7 is not equals to 1. If GCD of a comma 7 is 1, by Euler's theorem, a power pi of 7 is congruent to 1 modulo 7. That means a power 6 is congruent to 1 modulo 7. But what I need to expect is a power 37. So to get 37, again take the whole power 6. This is mod 7. This is a power 36 is congruent to 1 modulo 7. And I need to have actually, I need to expect a power 37. Again, I multiply with a. So a power 37 is congruent to a modulo 7. So this is by Euler's theorem whenever a and a7 are relative prime. So in another case, whenever a is not relative prime to 7, therefore automatically 7 divides a. That means 7 divides a minus 0. Again, by definition of congruence, a is congruent to 0 modulo 7. Therefore again, by taking a powers 36, a power 36 is congruent to 0 power 36, where 0 power 36 is actually 0 mod 7. Again, I am going to express a power 37. That means you need to multiply with a. That means a power 37 is congruent to 0 modulo 7. But 0 is nothing but 0 is congruent to a. Therefore, a power 37 is congruent to a modulo 7. So in both the cases, what you observe is a power 37 is congruent to a modulo 7. Right? Similarly, if you take a prime number 13, that means a power 37 is congruent to a modulo 13. Similarly, a power 37 is congruent to a modulo 19. Therefore, once you get this step, that means 7 divides a power 37 minus a, and 13 divides a power 37 minus a. Again, by this 19 divides a power 37 minus a. But you know the fact that product of a divisor is a divisor provided they are relative prime. So 7 and 13 are relatively prime. Therefore, their product also divisor of a power 37 minus a. And this is a 91. 91 divides a power 37 minus a. Again, 91 and 19 both are relative prime. Therefore, their product also divisor of a power 37 minus a. Therefore, 1729 divides a power 37 minus a. That means a power 37 is congruent to a modulo 1729. So this is what actually answer. So thank you.